Ever feel like, I don't know, like the universe is just too much, too vast, too complicated?
It can definitely feel that way sometimes.
Right. Well, today we're tackling that feeling head on. We're taking a deep dive into some serious cosmic rebels.
The thinkers who said, forget what you think you know about the universe. I think it actually works like this.
Exactly. We're talking Galileo, Newton, Einstein, Hawking, the heavy hitters of scientific revolution.
And we're not just talking about their discoveries, but also about their lives, their struggles. Because let's face it, genius often comes with a side of, well, complicated.
It makes you wonder, right? Like, what is it about these minds, these individuals, that allowed them to see what others couldn't?
That's what we're here to explore.
All right, so let's jump right in. First up, Galileo. Imagine living in a world where everyone, and I mean everyone, believes that the Earth is the center of everything.
It's almost impossible for us to grasp now, isn't it? This wasn't just some fun fact. It was woven into religious doctrine, scientific understanding, human perception at the most fundamental level.
And Galileo comes along and says, nope, that's it, just nope.
Well, he had some pretty convincing evidence to back it up. But yeah, essentially he challenged centuries of deeply ingrained thought with observations and logic.
And it's not like he was always the easiest guy to get along with.
From what we know, Galileo was, shall we say, a bit of a personality. Brilliant, absolutely a true innovator, but he wasn't afraid to step on some toes.
He made enemies as easily as discoveries.
That's one way to put it. That personality definitely played a role in his eventual downfall, but it also fueled his drive. He wasn't afraid to be wrong. In fact, he almost seemed to relish proving others wrong.
Which, in the pursuit of scientific truth, can be interesting.
The double-edged sword, for sure.
So, okay, we've got to talk about the telescope. Now, everyone associates it with Galileo, but it wasn't actually his invention.
True, the telescope was around for a bit before Galileo got his hands on it.
So what did he do?
He mastered it. He took this existing tool and figured out how to refine it, make it more powerful.
And when he pointed that improved telescope at the night sky,
Well, let's just say he didn't see what everyone expected.
what did he see?
He saw a universe far more complex, far more dynamic than anyone had ever imagined. He saw imperfections on the surface of the moon. He saw moons orbiting Jupiter, proof that not everything revolved around the Earth. He even observed the phases of Venus, which just didn't make sense if the Earth was at the center of it all.
So how did people react? Did they just suddenly say, oh, Galileo, you're right, we've been wrong all this time?
Not quite.
Figures.
Remember, this wasn't just about science. It was about challenging deeply held religious beliefs, centuries of tradition, the very foundation of how people understood their place in the universe.
And the Catholic Church, which, was kind of a big deal back then.
To say the least.
Right. They weren't too happy about having their worldview challenged.
Let's just say they weren't thrilled.
And the thing is, Galileo was Catholic himself, right?
Yeah. He was, which makes this whole clash even more intense. You'd think it would have made him more cautious, more diplomatic in how he presented his findings. But that wasn't really Galileo's style, was it?
No, not at all.
He was never one to back down from a good argument. In fact, he wrote this whole dialogue, basically a play, where he presented both sides of the debate, the Earth-centered view and the sun-centered view.
Yeah.
Let's just say the character arguing for the Earth-centered view, the one everyone had believed for centuries, didn't come off as very intelligent.
Oh boy, I'm sensing this isn't going to end well.
It didn't. You see, Galileo, in a move I'm sure he came to regret, basically modeled that character, the one who just didn't get it, after the Pope.
Yikes. You do not want to be on the Pope's bad side.
Especially not back then. The Inquisition, the Catholic Church's way of dealing with heresy, well, they weren't exactly known for their sense of humor.
It happened.
They put Galileo on trial, declared him a heretic, forced him to recant his views publicly, and sentenced him to house arrest for the rest of his life. That's awful. I mean, here's this guy who uses observation and reason to help reveal the universe as it truly is, and this is how he's treated. It really makes you think about the price of truth, doesn't it?
It does, but it's also a reminder that ideas, once they're out there, they don't just disappear, even if you silence the person who spoke them.
Even with that ending, Galileo's story, I don't know, it feels hopeful,
Oh, absolutely. Because even though he was silenced, his observations, his ideas, they didn't die with him. They continued to circulate, to influence other thinkers, to plant the seeds for the next revolution in our understanding of the cosmos. It's funny, isn't it? Galileo confined to his home, pushing the boundaries of knowledge from within four walls.
And yet,
his ideas, his observations, they didn't stay confined, did they?
Not at all. They rippled outward, influencing another brilliant, if somewhat reclusive mind, Isaac Newton.
Newton, talk about a legacy. This is the guy who literally wrote the book on gravity, among other things. Several books, actually. But yes, Newton's work was truly groundbreaking. He gave us the language to describe the universe in a way no one had before.
And to think, he did a lot of it in isolation.
He was a bit of a loner, Newton.
Yeah.
His childhood wasn't easy, which might explain some of that.
Oh yeah? What happened?
Well, his father died before he was born, and his mother, well, let's just say she wasn't exactly winning any parenting awards.
That's rough.
He ended up being raised by his grandmother, and I think that early experience of loss, of instability, it really shaped him.
So he turns inward, focuses on his work.
Exactly. He becomes intensely focused, obsessed even, with understanding how the universe works.
And that obsession leads to
Calculus.
calculus. He just invented a whole branch of mathematics.
Pretty much. It wasn't on a dare, or at least there's no historical record of a dare, but it's true that he developed calculus as a tool to solve a physics problem.
See, that's the difference between us and geniuses. I get a math problem, and I complain about it. Newton gets a math problem, and he invents calculus.
Something like that.
But okay, let's talk about the apple.
The apple.
Yeah, you know the story. Newton's sitting under an apple tree, an apple falls, and bam, he discovers gravity.
Ah, yes. Well, it makes for a nice story, doesn't it? The apple likely didn't hit him on the head, but the point of the story is that it got him thinking about gravity.
So it's true, he had this realization about gravity.
Oh, absolutely. But the real breakthrough wasn't just realizing that gravity exists. I mean, everyone had experienced that.
Right. What goes up must come down.
Exactly. What Newton did, what was so revolutionary, was that he realized the same force that pulls an apple to the ground also governs the motion of the moon, the planets, everything in the universe.
Wait, so he's saying that the same thing that makes this pen fall to the earth is what keeps the moon in orbit.
Precisely. It's this invisible force that acts across vast distances. It's universal.
That is incredible.
It really is one of the most important discoveries in the history of science. It completely changed how we understand the universe, our place in it.
And he wrote all of this down in his book.
He did. He laid it all out in his masterpiece, the Principia Mathematica. It's considered one of the most important works in the history of science.
I have to admit, I've tried to read it. It's not exactly light reading, is it?
Let's just say it's not something you'd want to take to the beach for a casual read. It's incredibly dense, packed with equations and diagrams. It reflects Newton's genius, but it also highlights his isolation. He wasn't writing for a mass audience. He was codifying his understanding of the universe.
And that's where we start to see the real shift, right? From simply observing the universe to trying to figure out its underlying rules, its hidden language.
Exactly. And with Newton, that language was mathematics. He gave us the tools not just to describe the universe as we saw it, but to predict its behavior, to uncover its secrets.
It's incredible to think that a guy who spent so much time alone in his study could unlock some of the universe's biggest mysteries. But then again, maybe that isolation, that focus, is exactly what allowed him to see what others couldn't.
It makes you wonder, doesn't it? If he'd been less solitary, less obsessed, would he have made those same leaps in understanding? Or do those breakthroughs sometimes require a certain level of, well, let's call it detachment?
It's a fascinating question, and it's one that becomes even more relevant when we turn our attention to another giant of scientific thought, Albert Einstein. Because if Newton was the architect of the cosmos, Einstein was the one who dared to reshape the very foundations of space and time. It's hard to imagine, isn't it? Being a young man full of life and then receiving this diagnosis that completely upends everything.
It's a cruel twist of fate, for sure. But in a way, I think that's what makes Hawking's story so incredibly powerful. He refused to let this diagnosis define him.
He refused to let it limit him.
Exactly. He could have easily given up, retreated from the world.
But
Instead, he dove headfirst into his work, into unraveling the mysteries of the universe. It's like this diagnosis, as devastating as it was, ignited something within him.
a fire.
A fire. A determination to squeeze every last drop of wonder and discovery out of the time he had left.
And he did. Even as his body failed him, even as he lost the ability to walk, to talk, to write on his own.
His mind, that brilliant, relentless mind, it never stopped.
He became this incredible figure, this icon of scientific curiosity, of perseverance, someone who refused to be defined by his limitations.
He became a symbol of the power of the human spirit.
and his work on black holes, those cosmic enigmas, those regions of space-time where gravity is so strong that nothing, not even light, can escape. I mean, how do you even begin to wrap your head around something like that?
Well, you have to remember that black holes, they're not just these, empty spaces in the universe. They're actually incredibly dense objects with immense gravitational pull. They're predicted by Einstein's theory of general relativity, but even Einstein, he had his doubts about whether they truly existed.
So how do we even know they're real?
There's a ton of observational evidence now. We can see how they interact with matter and light around them, how they warp space-time. But for Hawking, it wasn't enough to just know they were there. He wanted to understand them, to delve into their mysteries, and that's where things get really interesting.
Okay, I'm intrigued. Tell me more.
Well, Hawking had this incredible insight to combine Einstein's theory of general relativity with another core concept of modern physics.
Which is?
Quantum mechanics.
Quantum mechanics, the study of the very, very small.
Precisely. And it's notoriously tricky to reconcile with general relativity, which governs the very large things like stars, galaxies, and of course black holes. It's like trying to fit two completely different puzzles together.
Okay, I'm starting to see the challenge. But Hawking found a way to make those puzzles fit.
He found a way to bridge that gap. He proposed that black holes, those cosmic objects that were thought to be sucking everything in, devouring everything in their path, were actually leaking energy.
Leaking energy? You mean they're not completely black?
Exactly. He theorized that they should emit a faint radiation, what we now call Hawking radiation. And this radiation, it's a consequence of quantum effects happening near the event horizon, that point of no return around a black hole.
So even black holes, these ultimate prisons of gravity, aren't completely immune to the laws of the quantum world.
It was a radical idea, a profound insight that completely changed how we think about black holes. It suggests that they're not eternal, that over incredibly long periods they slowly evaporate.
So much for nothing ever escaping a black hole. That completely changes the game.
And it really highlights something fundamental about scientific progress, doesn't it?
What's that?
It's a relay race. Each generation of scientists, they take the baton from those who came before, building on their work, refining it, sometimes even overturning it.
And in Hawking's case, I mean, he wasn't just content with understanding black holes. He dreamed of something even bigger.
You're talking about the theory of everything. That elusive goal of unifying all the forces of nature into a single, elegant framework.
That's a pretty big dream.
It's the holy grail of physics. To find a set of equations that could describe the universe from the smallest subatomic particle to the largest galaxy, to explain gravity and quantum mechanics as two sides of the same coin.
Did he ever find it?
Well, not quite. It's a challenge that continues to fascinate and frustrate physicists today. But Hawking's work, it moved the needle. His insights into black holes, into the nature of space-time, they provided invaluable clues, new paths for researchers to explore.
So as we wrap up this deep dive, from Galileo challenging centuries of dogma with his telescope, to Hawking probing the mysteries of black holes from within a failing body, what's the takeaway? What's the common thread that connects these rebel geniuses across centuries?
I think it's that unwavering curiosity, that burning desire to understand how things really work, even if it means challenging the status quo, overturning long-held beliefs, or venturing into uncharted intellectual territory.
These were individuals who were never content with the easy answers, who were always pushing, always questioning.
Exactly. And it's that spirit of inquiry, of pushing the boundaries of knowledge, that I think we can all learn from, regardless of our backgrounds or professions.
Because the universe is full of wonders, and the journey of discovery is open to everyone. All you have to do is ask the question.
And never stop asking.